Welcome back. This is mini lecture 2 for Computer Science 163 at UWEC, and here we will be talking about passing parameters to functions by reference. The reading for this section, mini lecture is section 5.9 in our textbook, and I encourage you to read it before watching this video. Here are today's self-check questions, and again, the purpose of this is to help you practice recalling information from last time. It gives you a little bit of continuity from the last lecture, and then also helps challenge your ability to recall information. So I'd like you to pause, see how comfortable you feel answering these questions, and if you feel good, great, we'll move on. If you don't feel so comfortable, see if you can do the required reading for this summary on the previous slide, and then also perhaps review one or two of the most recent mini lectures as well. So what is a reference parameter? Well, suppose that you want to pass variables to a function and allow the function to modify those variables. Here's an example function that you might have. You might have a function called swap, and you want to pass it two integers, x and y, and then whatever value x has, it will swap values with y. So if x equals 1 and y equals 5, then after calling swap x and y, x will have the value 5 and y will have the value 1. So before x was 1, y was 5. Now y is 1 and x is 5. So this is what we'd like to be able to program. So let's see what happens if we just pass into a normal these values into a normal function called swap. So in our main method, we've got we define two variables a and b, and we say a is 1 and b is 5, and we can output them. A is 1 and b is 5, and then we call swap. Now when we call swap, what's going to happen is it's first going to copy over the value of a to the value of x. So a from the main method will now, whatever that value is, will get copied into a variable called x in the swap method. So a was 1, now x is 1. Then it will do that for all the other variables in this function. So in this case y, it'll copy the value of b over to the value of y. So now there are copies of variables a and b in the swap function, and now we're calling them x and y. So let's go on down in this swap method and go line by line and see what happens. In the first line of code, it's creating a temporary variable called z that's going to save the value of x, because on the next line it's going to get changed. So the value of x is, or the value of z will be equal to x. So the value of x is going to get copied over into z. Then on the next line of code, we're going to copy the value of y into the value of x. So x was 1, now x is 5. And then finally, we're going to take that value of the temporary variable z and copy that into the value of y. So now we have copied, whereas before we had x equals 1, y equals 5, now we have x equals 5 and y equals 1. Are we done? No. The reason for that is because even though x and y changed in the swap method, they didn't change the values of a and b in the main method. That's because x and y were copies of a and b, and so we swapped the copies of a and b, but we didn't swap a and b themselves. And because of that, there was no change to a and b in the main method. That's because we were passing by value, and that's the typical default for when we pass parameters into functions. It's usually faster for small variables like integers. So when we pass a variable to a function, passing by value, the function gets a copy of that variable's value, like we saw. So we copied in the value of a into variable x. We copied in the value of variable b from the main method into variable y in the swap method. That's what happens when we pass by value, and that's the default behavior for whenever we call a function. What we want to do is we want to pass by reference. Now when we pass by reference, the computer passes the memory address of the variable behind the scenes so that the function can use the actual variable itself, not just a copy of it. What does this look like? Let's take a look at that same function that we just saw, but now instead of passing by value, we're going to pass by reference. So the main method here is totally unchanged. The swap method has changed slightly, and I'll show you how in just a second. So let's start in the main method and continue as we did before. So we have a variable a, which equals 1. We have a variable b, which will be equal to 5. And then we call the swap method. Now let's look at what's different about the swap method. If you look at the swap method signature, whereas before it was swap, or void swap int x comma int y, that was the method signature for the swap method. Now we have a funny ampersand signal, or ampersand symbol after the integers. That tells us, the first ampersand tells us that we're going to be passing x by reference instead of by value, which is the default. And then the other ampersand is saying that we're passing the parameter y by reference instead of by value. So we're not just copying in the value of a into variable x, we're going to copy in the memory address. And so when we talk about x, it's really going to be referring to a in the main method. So here we go. When swap gets called, it will look at the variable a in the main method, and it will say, hey, this corresponds to variable x in the swap method. And variable b in the main method will correspond to variable y in the swap method. But it won't create a new variable there. Instead, variable x and variable y will refer to the same places in memory that a and b do in the main method. So x, in the swap method, we'll call it x rather than a, because if we tried to use the variable a in the swap method, a is not in scope. But x is in scope. We just basically have a different name for it. It's an alias, if you will. So in the swap method, when we talk about variable x, it will actually be changing the value of a under the hood. And when we change the value of y in the swap method, it will change the value of b in the main method under the hood. So now there are two different ways to get to this, to change this variable, whereas before it was just a and b. So x is going to have the value 1, and y is going to have the value 5. This is kind of the same thing as like it was before. The big difference is that before, a and x were totally separate variables. They were copies of each other, but they were like clones of each other. Here, we have x and a being two different names for the same variable in memory. And b and y are two different names for the same variable in memory as well. So let's go down and see how things change. So in the next line of code in the swap method, int z equals x, we're going to create a new variable called z, just like we did before, and we're going to copy the value of variable x, which is 1. So far, so good. The next line of code, we set the value of x equal to the value of y. Now, when we set the value of x equal to the value of y is 5, so we're going to set x equals 5. But when we do that, notice how it also changes the value of a in the main method. That's because under the hood, x and a are referring to the same place in memory. So if I change x, then I'm changing the same ones and zeros in memory that a refers to. So it changes the value of a as well. The next line of code changes the value of y equal to whatever z is. Z is 1, so that sets y equals 1. When we do that, that changes the value of b as well, because again, y and b are both pointing to the same place in memory, or they're both referring to the same place in memory under the hood. So when I change the value of y, it's changing the value of b because they both refer to the same place in memory. And that's the end of the swap method. Now, did this actually work? Well, let's see. Before we had a value a equals 1 and b equals 5. Now, after calling swap, now we have a equals 5 and b equals 1. Did it work? Definitely. A+. Now a and b have changed. we've done our job, and we have made a swap method that really does swap the values of A and B. But again, we can't do that just by passing by value. We needed to be able to pass by reference. When would you actually want to pass by reference? Well, as you just saw here in the previous example, whenever you want a function to change a parameter, one of the values that you pass into the function, you would need to pass by reference, because if you don't pass by reference and you just pass by value, the function will only change a copy of the variable. It won't change the actual variable in whatever method called that function. So if you want a function to change a parameter, you need to pass by reference. Then that function can change that parameter. You might want to pass by reference if you pass a larger object. For example, a string. Now, a string is a whole bunch of characters in a row. It could be 5 characters, it could be 1 character, it could be 900 characters. And when you pass a larger object, if I were to pass a string by value, then what the computer would need to do under the hood is it would need to copy, say, all 900 characters from that string from the main method to my function. And that would take a bit of time. Instead, if I pass a copy, or if I pass a reference, or if I pass the string by reference, then it will pass the location memory of that string, and it won't need to actually copy all those values, because those values already exist. Why do I have to change them, or why do I have to copy them? So the computer will spend less time copying that big old long object, and that can help you save time if you want to write high performance code. So let's see what that would look like. Let's say that I have a shout method, and the shout is going to print some text that I send it. It's going to print a string, and it's going to add 3 exclamation points to the end of that string to make it shouting. Ah! So how do we pass that by reference? We add that ampersand again, right after the type of the variable, of the parameter. And then what will happen is when I call that shout method and give it a string, it will pass a reference to that string. So it won't copy that string into this method. Instead, it will just use that string from wherever I'm calling it from, maybe my main method, and it will print that out and add 3 exclamation points to the end and then add a new line. So in this case, this shout method is a lot faster because I added that ampersand sign, which tells the compiler that I want to pass by reference. What if we want to pass a large object by reference, but ensure that it does not change at all? So for instance, maybe I want to write a function where you pass me a string, and I don't want to change the string in this function. I want to make sure that the string won't be changed, but I still really want that speed of passing, or the efficiency and the speed of passing the string by reference, not having to copy it all. Is that possible? And the answer is yeah. We can use the const keyword in our method signature to make sure that the object does not change. So now, in this method, I can call shout, and the shout method says const string ampersand text. So what I'm doing is I'm passing a string called text into this function by reference. So what's going to happen is the shout method is going to get the memory address, or the location in the computer's memory where this text is from some other method, maybe my main method. And this shout method is going to make sure that nothing is going to change the values or the characters in this string called text. I can read from that variable, I can get its value, but I can never change its value. And so this is something that can help make your code more robust. If you know that you're writing a method where you pass something by reference, and you know that you don't want that parameter that you're passing by reference to change, then you may as well add const to it. That ensures that it won't accidentally change. And this is a really good way to help prevent errors in your code. And you might say, well, Jess, if I look at that method right here, why would I be changing that variable? And you would be right. There's nothing in this variable that's going to change the value of text. So why would I want to use the const keyword? Well, in this example, you don't really need to. But in more complicated examples, you might write a function where you're like, well, I don't really, I don't change the value of this variable, but then maybe you call another function or routine that does possibly change that variable, and you weren't aware that it was being passed by reference, and somehow something changes. Those errors can be really, really hard to track down. So I'll just leave it there and just say it's a really good practice in general to make sure that if you can pass something as a constant, or if you pass something by reference, then if you want it to be constant, or if you don't need it to change, then make sure you pass it as a constant reference. It's just a good programming practice. So in summary, here are a few questions that I'd like you to think of that would help you maybe review a little bit of what we talked about. What does it mean to pass by reference? What are the advantages of passing by reference? And when would I want to pass by const reference, and why? So I encourage you to take a little bit of time to pause here at the end of this video and maybe jot down in your notes some answers to these questions. Then maybe go back through this lecture and see if you got those answers right. If so, great. If not, contact me. I'd love to get in touch with you. Till next time, everyone, thank you for your time. Bye-bye.